again. Next up, we have Gian Merlino, CTO and co-founder of Imply.
Hey, everybody. Thanks for coming to Druid Summit and thanks for coming to this talk. I'm Gian Merlino, a committer and PMC member on Apache Druid and a co-founder of Imply who's hosting this conference. When we started Imply, we started it in order to take Druid to what we saw was the next level for Druid at the time and enable it to be used by more people, get in the hands of more people, and become easier to use. We built things like Imply Cloud. We contributed a ton of stuff to Druid around SQL, vectorization, performance, and what I want to talk about today is what we see as the next step in that journey, what we see as the next evolution of Druid, the next level for Druid. Now, of course, I can't talk for everybody. I can't talk for the entire project. Apache Druid is a community project, but I'll be talking about at Imply the things that we think are really important to invest in, things that we intend to be building. The context for all this is that we're at an inflection point. Where we're at as an industry is that modern analytic applications and the need for them is really exploding. There's something that started in big tech. They started with big tech companies. Those are the first adopters of Druid and databases like Druid. But what we're seeing now is people recognizing the value in providing analytic applications, interactive analytic experiences to internal users and external users at massive scale. And in order to take Druid to the next level, to make it work for the kinds of applications people want to build over the next year or two, we need to embark on a journey of really improving it in a lot of key ways. And so I want to talk about what those key ways are. But before that, I'm going to talk about a cool name for the project. And the inspiration here is Confluence Project Metamorphosis. This is something that our friends at Confluent did last year to take their product and to take Apache Kafka to the next level. I remember when it first came out, when I first read the info about it, I thought it was pretty cool. I thought it was really neat to see a vision sketched out for what Kafka could become and what products based on Kafka and what experiences based on Kafka could become. I thought that was inspirational, and I was happy to follow the success of that project. And here at Imply this year, we are going to pay homage to that and call our project Project Shapeshift. So what does Project Shapeshift mean? We're going to have three pillars: cloud native, simple, and complete. These are the three areas that we think we're going to get the best bang for our buck investing in over the next year in the overall Druid experience. So cloud native, what does that mean? Cloud native means building a true serverless SaaS experience. Simple. Simple means just having a system with low conceptual weight, easy to learn, easy to use, and this hits across a wide variety of areas of the system. And then complete. Complete means completing an architecture that enables all the kinds of features that people want when building an analytics application. Some of the changes we're going to be making, or some of the work we're going to be doing as part of Project Shapeshift will make its way into Imply products. Some will make its way into contributions to Apache Druid. And so stay tuned over the next year for announcements in these areas. And the rest of the talk, what I'll be doing is diving into each of these three areas and talking about the kind of work we're going to be doing in each area. The first pillar here, cloud native, the thing that we're trying to do here, like I said, is create a true serverless experience. There's a bunch of things we have to do to make that work, and I want to talk about what those things are. So the first thing is getting rid of tuning parameters. Getting rid of tuning parameters is really important because when you interact with a serverless API, you don't expect to be talking about things like memory, disk space, threads. You expect the API to just kind of do what you tell it to do without needing to worry about the hardware details. And you want to have that fiction that there is no servers behind it. Druid, of course, does have a lot of tuning parameters. And so there's a lot of work that we have to do in making it so the variety of workloads that people want to do with Druid can actually be executed without needing to worry so much about tuning things. We need to make the system much more adaptive to the hardware it runs on without explicit tuning. Another important one for a serverless system is abstracting hardware boundaries. Sort of similar, maintaining the fiction things are serverless. So you don't want to think about running out of disk space. You don't want to ever see an error that you're out of memory, that you're out of disk space, this kind of stuff. We want to make sure that every resource is protected. So every resource either has to have guardrails that you mean, by that I mean the product prevents you from hitting those resource limits before you actually hit them, or it has to be auto-scaling, meaning that it appears effectively infinite. And so for all the kinds of hardware resources out there, we need to make sure that one of those two things is happening. Another one is we need to augment the ingestion API. This one's important because Druid's ingestion API today is oriented around a pull-based design. So you connect Druid to Kafka, you connect Druid to Kinesis, you connect it to cloud object storage, and Druid pulls data from those systems. This has been a very successful design for building a singular analytic system in a single data center. All the Druid able to pull from sources of data and load that data within itself. However, with a serverless experience, you may not want to give a vendor of a serverless API the ability to connect to your Kafka cluster. You may want to just take data out of your Kafka cluster and push it in with an SDK. So building a push-based ingestion option is something that will be really important to make this work. And our thinking is that with these things being done, and of course a lot of other blocking and tackling, we'll be able to deliver a true first-class, world-class serverless service experience for Druid. An experience that is not just serverless, but also auto scales and also has the potential to offer usage-based pricing rather than capacity-based pricing. All the kinds of stuff that you would really expect in a world-class serverless offering. These items, these Druid items, and these service items are things that we're working on at Imply right now. So expect to see some announcements over the coming year about in this area. So stay tuned. Till then, I'd like to talk about the next pillar, simple. Simple is something that's really important to me. I think that what we're really trying to do is give people the ability to use the power of Druid, access the power of Druid as simply as possible. Things can always be simpler, but the big challenge with making things simpler is not limiting capabilities. And that's actually pretty hard to do. It's pretty hard to make a system that has a low conceptual weight, is easy to learn, and yet is still very powerful and very capable. I think that there's improvements that can be made to Druid in this area in a wide variety of regions, in the area of ingestion, querying, operations, you name it, data management. The one I want to talk about right now and dig a little bit deeper into what we're thinking is in the area of ingestion and how we're thinking about making that simpler. So our big idea here is to extend the SQL API to support not just querying, but also ingestion. And a little bit of background here. Druid, when it first came out, did not have a SQL API. When Druid first came out, there was a query language that was JSON-based. It was something unique to Druid, so it was something you had to learn. And it also had a JSON-based batch ingestion API, also unique to Druid and different from the query API. At some point, we introduced Druid SQL. That was actually one of the earliest contributions that we made it Imply to Apache Druid right after founding it. And I think it was a really great feature. I think it's been very successful. Today, so many users of Druid, so many people developing on Druid are using the SQL API to write their queries. And it makes sense. SQL is a concise language, more concise than JSON, more approachable. And also it's something that a lot of developers already know and they're already familiar with. So what we're thinking about for the future of Apache Druid is developing and contributing an experience that enables using SQL to do not just query, but also ingestion and transformation of existing data. And this is really exciting because it means that the other major complicated JSON-based API in Druid, the ingestion API, will be able to be unified with the SQL language, making that much more accessible to developers. We think that by combining the ingestion and query systems and languages in this way, it will simplify the tuning and simplify the configurations that need to be dealt with during ingest, and also give the ability to do re-ingestion and transformation using queries, the ability to save the result of a query to a table, enabling a lot of powerful data architectures. So the concept here is giving developers the ability to do data operations through SQL, not just querying, but data management as well. So there's a lot of reasons that doing ingestion with SQL is cool. I think that the coolest thing is how much more concise the language is, how much more approachable it is. What we have on the left here is a pretty simple ingestion being expressed as the current Druid batch ingestion JSON spec. And even though it's a relatively simple ingestion, what you can see is that it's actually looking quite complicated. The JSON file is pretty long. It's actually hard to imagine writing this by hand. And in fact, I have not written an ingestion spec by hand personally in quite some time. I usually use the Druid web console to build it for me, and then maybe I make some tweaks. That's how tough they are to build up. So I think that giving the ability to write these ingestion specs or to initiate ingestion using SQL is really powerful because you actually can imagine just writing one and letting it go. It's much more approachable, and it's a language people already know. And most importantly, it's the same language that is used for the query system. So there's only one language to learn instead of two. And other benefits as well, the ability to use Druid query functions, Druid SQL functions at ingestion time for things like joining, enriching is really powerful. And also by running ingestions through the query system and by combining the systems a little bit more, reducing the amount of tuning parameters is also something that is really exciting. So now I'd like to do a little bit of a demo of what ingestion with SQL might look like. So here we have the Druid Web Console that you know and love, and I want to use the Druid Web Console to show you a vision of what data ingestion would look like once we unify the ingest and query APIs under the same SQL language. So I'm going to paste in a query here into the query tab. It's of course a SQL query, but it has a couple new keywords I want to highlight. One is insert into. So this is the table that we're going to be loading the data into. And the other one is we're actually selecting from external data. So the external data file I have here is web analytics data, web traffic data from one of my favorite websites, koalastothemax.com. And I'm just going to load in every column in this table or in this data set, as well as I'm going to parse the timestamp. So like the data ingestion view, or like the data ingestion tool that we already have in Druid, there's a preview feature built on a sample of the data that allows you to see what it's going to look like before you ingest it. And we'd also like that to be powered by the same SQL language. So here we see a preview, a little sample, it looks right. So we're going to insert that data into a table. And as this runs, we actually get some little counters that count up while it's running, showing us the progress of the job, how much data has been processed so far, and see it get written into the actual table. So let's wait for this to finish. So now I want to show a more complex ingestion using more of the features that Druid has to offer. The first thing I want to highlight here is actually not related to the ingestion at all. It's just a SQL feature that I'm using to make the query look a little bit more organized. I'm using this with keyword to define a few external data sources at the top of the query. So I have KTTM data, that's the same data file I loaded previously. And I have country lookup, which is a lookup file from a country code to country name and capital of that country. So let's look at the query now. I always think it makes most sense to read select query starting from the from. So let's do that. We're going to select that raw data and we're going to join it on that country lookup. So this is an ability to do a join during ingestion time. We're going to do a filter during ingestion time as well. And here we're doing rollup. In the classic Druid system, in the classic Druid ingestion spec, you would say, I want to have dimensions and I want to have rollup. With SQL, that's just a simple group by. So I'm grouping by 22 dimensions. Some of them coming from my base table, some of them coming from my lookup that I'm joining in. And I'm also going to have a few aggregations. I'm going to do a count, I'm going to do a total session length, and I'm going to store a sketch of approximate count distinct. This is going to be a hyperlog log sketch. And finally, I'm going to do some partitioning. In ingestion, the partitioning is going to be controlled by the order by clause. So let's first do a preview of this to make sure we got it right. You see the query structure is a little bit more complex, or a little bit more complicated because we're doing a roll-up query here. Okay, so here's our preview. Data looks good, so let's insert it. Great, now that it's finished, let's query that table we just ingested to see what we got. Because we're doing roll-up here, we should have fewer rows than the input data. So let's do a query that illustrates what our roll-up ratio is. So I'm going to still do a count star to see how many rows are in this table, but I'm also going to sum the ingested count to see how many rows were originally ingested. So we see here, we ingested a little over 100,000 rows. We did have that filter, so it's smaller than the 500,000 from earlier. And that rolled up to about 39,000 rows. All right, well, that was a little demo of what inserting data into Druid through SQL would look like. I think this is super exciting. I think it's going to really take the simplicity and ease of use and accessibility of Druid much, much further than it is today. And I'm really excited to be rolling this out over the next year. So stay tuned. Third and final pillar I want to talk about is complete. And complete can mean a lot of different things. And for us, for Project Shapeshift, what complete means is really completing a architecture for building modern analytic apps that has Druid at its core. And I want to talk a little bit about what that means. So let's analyze what I think developers want to do with analytic applications, what people tell us they want to do when they talk to us about the apps that they're building. I'm willing to bet that most of you here at Druid Summit are here because you picked up Druid for its ability to do interactive queries. This is what Druid is known for. This is why Druid is so good at powering analytic applications, the ability to do sub-second responses on nearly any scale of data the ability to handle really high concurrency, and the ability to do that on data ingested streaming in real time or in batch. This enables Druid to power what I would say is the heart of a modern analytics application, which is an interactive real-time query experience. However, there are other requirements that do come up in modern analytics applications that Druid by itself may not be the best solution for handling. One is reports. So reports have a set of requirements that are very different from interactivity. One is handling very large result sets. A report might have millions and billions of results. It might have even more than that. A interactive query tends not to have that many results because it's designed to be shown on the screen, and so it's going to have a number of results commensurate with what you can show in a browser. Another feature of reports is different from interactive queries. They might run much longer. They might be more complicated, hitting more ranges of data, doing more complex operations. They also tend to be very resource intensive and yet infrequent. So interactive queries tend to be issued at very high concurrency. And individually, each one is not terribly resource intensive. Reports are the opposite. They are issued at generally fairly low concurrency, and each one is generally much more intensive than an interactive query. And how do people build these features today? This feature might be called report, it might be called download, it might be called export. Whether it's called one of those three things, it's the same kind of feature. There's a couple of approaches that we see people take. One approach is to try to build it on Druid and try to make the Druid system work for these reports. That does have some legs. You can extend the timeout for the queries. The default timeout is 5 minutes. You can make that longer if you like. You can tune the system to be able to handle very large result sets. But at the end of the day, the fact of the HTTP-based request response format and the fact that the query results are sent through a single query server does not make it an ideal system or an ideal architecture for doing these very large and very resource-intensive reports. Another option that people do is take the data that is going to be landed into Druid and also land it into a data lake, and then use something like Presto or Spark for reporting and use Druid for interactivity. This is a very common architecture. If you go online, search for Druid Presto, Druid Spark, you'll see a ton of people using them together in this way. Of course, the big downside of this architecture is that it's complicated. You have to have two systems. You have to make sure data is in sync. You have to manage the data separately. There's a lot of overhead in this approach. Another feature that people want to have in analytic applications that has a similar issues is alerts. Alerts is something that if you want to build analytic-based alerts, thing based on moving averages, so on and so forth, it's relatively straightforward to see how to do it for a small number of alerts. You might do a query for the older data, a query for the newer data, compare them. If they're different enough, then issue an alert. However, what happens when you have millions of alerts? What happens when you're tracking really large numbers of objects? What happens when you have complex analytic conditions? In these situations, doing alerts through database queries tends to have some of the same issues that reports have. You tend to have resource-intensive queries. You tend to have very large result sets, long-running queries, this kind of thing. So another solution that people have is to try to do this with dual processing with another system. You might land the same data in Druid and also process it with a stream processor, like Kafka Streams or like Flink or like Spark Streaming. Those systems are really great at doing alerts, but again, the overhead of having two not very in sync systems as part of your architecture can make your overall architecture very complicated. So, as we can see, none of these solutions that people are doing today is really ideal. And I think the ideal solution has Druid at its core. So looking at Druid's architecture is really designed for interactivity. It has always on compute. It prefetches data. It does have this separated cloud storage layer, but it is prefetching things, not querying from the storage layer during queries. This enables Druid to achieve super high performance, super high concurrency, and kind of give it that feel of super interactivity and low latency. However, these same things are also not ideal for doing very long-running queries that return very large result sets. It's more non-interactive stuff. And I think that the general idea of having an engine that handles that is a good idea. And so we're thinking of is introducing a decoupled query layer that sits alongside Druid, but is very tightly integrated with it. And I want to talk about how that might work. So you have a separate compute layer here, and the separate compute layer is hooked up to the same cloud storage that Druid's hooked up to, and is very tightly integrated with Druid. It's really, really important that the integration be tight because we want it to feel like one system. And what that means is we want all the data ingestion to happen through Druid. We want all the data management to happen through Druid. And we want Druid to kind of be running the show. and this decoupled query layer to be something that is able to handle some of these other non-interactive use cases, things like older data, things like reports, downloads, exports, and so on. And so what we're going to be doing over the next year as this third pillar of Project Shapeshift is actually developing this query layer as part of the Imply product. But something else that we're doing that to support it is we're going to need to be making a lot of changes to core Druid in order to support this really tight integration. And I know that there are a bunch of integrations with other query layers in the community, things like integrations with Presto, integrations with Spark, integrations with Hive. And I really hope that the changes we're making in core Druid to support this tight integration are also going to improve the quality of all integrations with all query engines, making Druid a really great thing to be at the heart of any modern analytic application architecture. So that's Project Shapeshift, cloud native, simple, and complete, taking Druid to the next level, taking the Druid experience to the next level. A lot of this stuff is going to make its way into Imply product announcements over the next year. A lot of it will make it into contributions to Apache Druid from Imply over the next year. I really encourage you to stay tuned for both. It's going to be really exciting. And also enjoy yourselves at the rest of the conference. Thanks for coming.
What a great day. I want to thank you all for coming and spending your time with us, and especially to our speakers who put together some excellent content. We're going to be doing the same thing again tomorrow, same time, same place, and in the afternoon, we are going to be launching our inaugural training and accreditation program for Druid Basics. We'd love to see you there. Until then, bye.